Hi everybody, welcome back. So my wife and I the other day were at a antique store out of town, and I happened upon in the middle of the store this big hulking looking speaker, and I recognized it right away when I saw it that it was a Leslie tone cabinet. Now my cousin has been looking, he collects them, he's really into this sort of thing, and I knew he might be interested in it, so I took a picture of it, sent it to him, and he said, oh yeah, definitely, see what he wants for it. So I asked the owner how much he wants, and he offered a very, very generous, fair price for it, which when I told my cousin, he couldn't, he almost came through the phone trying to get it. So he asked me if I would purchase it and he'd pay me back. And I said, how am I going to get this gargantuan thing into my car? And I'll put some pictures up on the screen here so you can see what this thing looked like. And I had my SUV with me. And long story short, it was an adventure, but I was able to acquire this thing for him, fit it in my car, and drive it all the way an hour and 10 minutes back home. And I put it in my storage unit. And this is the amplifier out of it. Now, what is a Leslie speaker, you might ask? Okay, many of you probably know what they are, but for those of you who don't, a Leslie speaker is an add-on amplified speaker that is designed to be attached to an organ. And originally, the first ones were designed as an add-on feature to a Hammond organ. And a Hammond is an electronic organ that came out, I think in the 1930s or 40s, something like that. And it's known to have a very distinct sound. Any of you that have listened to any kind of music over the last, from the 1950s up into the, present times, would know the Hammond organ sound with the Leslie speaker if you heard it. So some examples. If you listen to the rock band Boston, the song Foreplay and the song Long Time, they feature a Hammond organ with a Leslie tone cabinet. Very unique sound. Magic Carpet Ride by Steppenwolf. Just about everything, any song you ever heard by the group Deep Purple. Carry On Wayward Son by Kansas, if you listen to the organ part in that. It's a Hammond organ with a Leslie speaker. I can go on and on and on and on and on. There's so many, it's everywhere. So it's a very distinct and unique sound. And the way that they're making that kind of vibrato type sound that you hear in that organ music is through these Leslie speakers. Now, how do they do that? Well, you have a primary speaker unit that usually will handle the bass and the main part of the sound of the organ. But what makes a Leslie different is it also has a speaker that rotates. Why would you want to rotate a speaker, you might ask? Well, as the speaker is pointing towards you and then moving towards and away and towards and away, it's almost like when you hear a siren. Did you ever notice when you hear a siren, as that siren turns, the sound gets louder and softer. But not only that, the tone, the pitch actually changes, and that's called the Doppler effect. And the Leslie speaker takes advantage of the Doppler effect, and it causes a very unique vibrato type sound. Now Leslie calls it tremolo, as you can see on here, but it's really more than just tremolo. It's also more of a vibrato sound because you actually hear the pitch shift from the Doppler effect. And different models over different years, they changed and updated the design. This is a very early one. And it was not designed for a Hammond speaker or for a Hammond organ. It was designed for a Conn organ, C-O-N-N. And it has some electronic differences, and it has a lot of similarities to the ones that were designed for the Hammond. And to my understanding, Hammond and Leslie really didn't like one another because Hammond had their own tone cabinets without the rotating, Doppler effect speaker, and this really cut into his sales. So became a very popular item, and to this day they're still selling them, I believe. They still make them. Of course, they use transistorized amplifiers and so forth. So anyway, the cool thing about this amplifier, and we're going to fix it up for my cousin before he comes and picks it up, is when I rotated it around here, lo and behold, there's a schematic on it. And I looked on some of the forums when I first picked this thing up before I removed the amplifier from the tone cabinet. And everything I'm reading is that nobody seems to have a schematic for one of these. If you go on all of the Leslie speaker forums and there's dedicated websites and everything to this, and there's organ websites dedicated to these speakers. Nobody seems to have a schematic for a 55C. They have the 50C, the 51C, which are very similar. The amplifiers are very similar, but the wiring is different. And the way that they channel the sound between the tremolo amplifier and the main amplifier is different. And the way this thing works is you have two amplifiers on this chassis, believe it or not. You have the main amplifier. It's a 50 watt. You can see how big this transformer is. It's a 50 watt amplifier that uses KT88 or 6550 output tubes. It's pretty stout. And then there's a secondary amplifier that drives that drum with two little speakers. Now this one, again, there's different rotating drums for the different models of Leslie speakers. The earlier one, which this is, has a drum-shaped device that has two little 6x9 speakers facing opposite directions, and they rotate inside that drum. That drum rotates in the cabinet, and that's what gives you your Doppler effect. Later models went to these horn devices, and they were very slender, and they kind of flared out and curved, and they also pointed in opposite directions, and they rotated as well, and the speaker was down below playing up into the horn. And the horn deflected the sound around. Those are the later models, and I believe they're more desirable. And then in addition to that horn, they had two stationary speakers on the sides of the cabinet facing out. But regardless of which one you have, there's a secondary amplifier that drives those speakers, and that's what this smaller set of 6973s is there for. And you see this tiny little transformer. This is only about a 5 or 7 watt amplifier for that, but the rotating speaker or the vibrato speakers, those ones don't really need a whole lot of power because they're really there for that sound effect. And usually they only amplify the mid-range tones and so forth and not the bass frequencies. So you don't need as powerful of an amplifier for that as you do for the main amp. The main amp drives a great big Jensen 15-inch woofer or low-frequency driver. And then it also drives a 6x9 to handle the upper frequencies. So in this particular cabinet, there's a total of 4 speakers. There's the 15-inch bass driver, a 6x9 stationary, upper frequency driver, and then 2 6x9 in the rotary drum for the vibrato effect that are connected to this. Now, the way it switches the sound to turn the tremolo on and off is different between the different models, and I don't know a lot about Leslie. This is stuff that I've read. There are people who really are experts on this. They know way more than I do. My goal today is just to fix this amp and make it work and clean it up and make sure it's safe and all that and make it back to its original glory. And to also look at the schematic, which is very unique. You'll see that this is not designed like your average guitar amplifier or musical instrument amplifier or even an audio amplifier. It has some cool features that we're going to go over as I was looking at this that I thought would make an interesting video. So without any further ado, let's get to work on this thing And the first thing I want to do is some tests before we actually apply any kind of power to it and get familiar with the circuitry. Now, anytime I check an amplifier, especially a vacuum tube amplifier, the very first thing I check before I go anywhere else is I look at the power supply, and then I look at the transformers. If the power supply or the transformers are damaged, it could be a game-ending situation, or it could at least be a scenario where you could damage other things if you don't take care of that first. Power supply is first. So that's what we're going to do. The first thing I'm going to do, I'm going to check this cap out. I'm going to pull all the tubes, as you've seen, see that I've done here. And then when we apply power, we're just going to check the transformers to make sure they all have their proper outputs. And then we're just going to statically check these output transformers here. This is a choke coil, just one single coil in there, and that's for the filter. And make sure that's all good. And if it's good, then we can proceed with the rest of the circuit. Okay, since we have this cap out, we're going to check the ESR on it first, and then we're going to check it for leakage. Keep that in mind. And these caps probably will need to be reformed. So that one's 3.5 ohms, 1 ohm, 1 ohm. And you can see all three of the 30 microfarad ones read exactly the same. So that tells me that this is going to be okay. And then here's the other one that's just lower capacitance yet. Okay, so those are good. And just to compare to a brand new, here's a brand new capacitor at JJ Electronics. It's a good cap. 47 mics. These are 30, but similar situation. And you're going to see very similar in reading. Now, again, this cap probably has not had power applied to it in a very, very long time. So it's probably going to need to reform a little bit anyway. And that doesn't mean that it is a bad capacitor. That means that the chemistry in there will need to reform. We'll try that. If it's good, we're going to leave it. Because a lot of these older caps last a very long time, and they very rarely fail. Some of them do, but some of them last many, 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 many years. And I don't think that my cousin wants to put any more money in it than he has to. And if he wants to plug a new cap can in there, I'll let him do it. I just want to make sure for now it's going to be good enough. And you can see what I mean about this capacitor here, how these things hold up. This is a 475 volt, 30 microfarad cap. And I'm charged all the way up to 465 volts. And you can see I'm on the most sensitive scale. I am only looking at 6 microamps of leakage right now. 6 microamps. That is just unbelievable. I mean, this cap probably hasn't had power on it in years, and look how it is. Now you can see it climbs up and drops down. You see that? That is the capacitor forming. Now remember, we're not, this meter is extremely sensitive. We're looking at the, each one of those little dashes is 1 microamp of current. So you can see as the cap forms, kind of goes up and down a little bit. But it's good. Okay, let's just do some static testing on here. We'll check some of these resistors. They all look pretty good as far as, the leads and everything. None of them look discolored or burned. So there's a 2.2K. Another 2.2, and it's 2.4. They're all reading 120K. It's reading 126. Another 120K, 126. Another 120K. That one's almost to 130. I mean, they're all off a little bit, but not bad. There's a 120. There's a 220K. There's a 120K 1 watt. Another 120K 1 watt. 56K. 59K, that's not terrible. None of these are what I would consider needing to be replaced. There's an 820 ohm. There's a, what is this, 18K. 220K again. 220K here. Okay, here is the cathode resistor for the outputs, the 6550s. It should be, according to schematic, it should be 100, what is it? 120 ohms is what it's reading. Let's see what it says here. Here's the schematic. And I believe that's 125 ohms. And it's reading, and this is a big ceramic resistor that sticks out the top of the chassis, 121. It's perfect. 10K on the capacitors. This is a dropping resistor for the power supply. It's saying 11K. It's a little bit high. There's a 1 meg, or I'm sorry, 150 ohm resistor, and it's reading 165. So it's a little high, not bad. Let's see, another 12K. I think I checked this 220K right here. All right, so they're all pretty good. And then this is the cathode resistor for the driver for the main amplifier, the 6550 amplifier. And it is a 300 ohm sand resistor. And that would be, let's see, right here. So here's the two cathodes of the, oh, I'm sorry, of the 6973 amplifier. So here's the two cathodes tied together, 300 ohm, 10 watt. It's that big sand resistor. And this lead should go to chassis ground, and it does. And this one, 700K. That resistor's open. So we have one bad resistor. So we have an open cathode resistor for the 6973 section for the low power amplifier. So we'll just call this high powered amp, and this is the low powered amp side. And those are bad. So this one's bad. So so far there's only one bad resistor. And what we're going to do is we're going to use this meter right here because it has a 30 volt battery for the high ohms section, and it works really well for testing, you know, for kind of in-circuit testing of those film capacitors, or paper capacitors I should say. All right, let's zero that out a little bit. Okay, and yes, I'm not looking on it real straight or anything, but we don't care. We want to make sure that we have, you know, high ohms up in the mega ohms. So that one's good. Good. Okay, if I'm not reading across something, that one's shorted, but we could be reading across something here. So that one we'll come back to. That one's good. Doesn't mean these aren't open, but at least it means they're not. Okay, there's another one we're reading something across. That one's not too bad. So we have these two here, which could be shorted, but I would have to remove one leg to make sure that we're not reading across something. So this one and this one are questionable. I'm sorry, maybe they're not. Hold on. Okay, yeah, so this is the only one here that's questionable. It goes from pin 9 of one of the 6973s to pin, let's see, to pin 2 of the other one. So if I go from pin, so that would be right here, Yeah, there's really nothing there but this 12K resistor. Okay, just out of curiosity, I pulled one leg of this, and it's good. It's high resistance. Yep. Very good. So that's good. There's a teeny little bit of leakage, but all these paper caps are always going to have a small amount of leakage. That's just normal. That's how they're made. They're not like a regular, like a polyester or polyethylene film capacitor or whatever. Not the same. So, okay, so they're good enough that we can at least put some power. And again, I didn't apply voltage to them or anything, but as long as they're in that 20 meg range and they don't, the leakage is good, we'll still need to check these two real quick, and I'll do that. But first of all, let's test those two tubes, because if this is open, chances are that one of those 6973s may have taken some abuse. Okay, we'll start off by checking for shorts, and this light should only light on A and H. So A, it's lit up. H, it's lit up. And we're good. Let's put this back on C. Let's look at our grid leakage. All right. That looks good. No grid leakage. And emissions. Emissions are good. So this is a good tube. All right, let's turn that off. Let's try this other one. Make sure it's good. Okay. A, H, all is good there, no shorts. Grid leakage, and nothing there. And emission. And that one's good too. So those are good. All right, that makes me happy that we don't have any damage. So really we're just going to need to find another 300 ohm 10 watt resistor. Okay, I have the mains connected, and we're using the smallest current limiting bulb in our isolation transformer. And I'm connected right now to, let's see here on the schematic, I'm connected to these two red leads, and that's going to be, since this is a 400 volt B plus, this is probably, it's going to be really high. It's probably going to be like 800 or 900 volts, something like that. So let's turn it on. Okay, that might be okay. So there's 650 volts, and I do have a little bit of glow on the bulb, more than I would expect. So you can see that bulb is actually glowing, and it shouldn't. It's not bright, but it shouldn't be lit up that much, considering there's absolutely nothing connected to the transformer. It should be just very minimal current. So I don't like that right away, but we'll see. Maybe it's okay. Let's go to here and here, and this is going to be our 5 volt winding. I just want to make sure one of the windings isn't shorted or something inside. Okay, so turn this on. And there's your 5 volt winding. It's a little bit low, so that could have a shorted turn. So that should be 5 volts, and it should be higher, a little bit higher than 5 volts with no load on it. So that might be something. So let's go to our 6.3 now. Those are over here. There's only 3 windings on this transformer. It's pretty simple. Okay. there. Let's turn it on. Okay, 5.6. So I guess that's should be okay. So our windings all have voltage on them, and maybe that transformer just has that, you know, that kind of loss in it. It's possible. But transformer's good, and it's definitely not shorted. Okay, we're going to just step this project up a little bit here because my cousin's coming to pick this thing up tomorrow. So I want to get it all done this evening, and that should be a pretty easy thing to do. I cannot believe it. I looked in my ceramic resistor stash, and look what I found. Brand new. 300 ohms, 25 watt. And this is a 300 ohm 10 watt, so this will be more than adequate. Wow. I didn't think I'd have one, but I just thought I'd check, and sure enough, there it was. So the rest of these resistors I think are well enough in tolerance, they'll be fine. I will probably replace these two capacitors because they are both getting those little hernias on them. I don't know if I can get zoomed in close enough for you to see on this one. See, I just won't quite focus, but you can kind of see right here where it's starting to bubble up. And that's usually a good sign that it's time to replace it. So I'm going to replace these two caps, and the new ones will be a lot smaller. These ones don't necessarily read bad, but I will replace them before I turn this over to him. But let's start just by replacing this and turning the thing on, and let's bring it up slowly and see if the thing will actually work. Okay, the two caps and the resistor are fitted in there. Let's flip it over, put the tubes in, and let's just see if we can get it to turn on. Okay, I think I have this all in frame. Let's turn this on. Now I am on the smallest current limiting bulb, so it's not going to allow full power. It's only a 40 watt bulb, but let's turn this on. And of course you can see there's 1.3 volts on there, roughly. And that's dielectric absorption of that capacitor. I did check that, by the way, on the Sencor LC102, and it did show that it had quite a bit of dielectric absorption. But these CAN capacitors, some of them do that, and it doesn't hurt anything in this application. So let's turn it on. And I've got a full bright light. Let's see if we have some filaments. And that bulb is not, absolutely not dimming down whatsoever. It's almost like a dead short. So let's turn this off. Let's remove the rectifier tube for a second. Maybe we have a shorted 5V3. You know, that's entirely possible. Again, we don't know what all's wrong with this amplifier or why the... Okay, let's turn this on now and see what happens. It's still pretty bright. So that could possibly be that there's just, the filaments are just way too much for this bulb to be able to handle the current. So I'm going to go to a larger bulb. Okay, we now have a 100 watt bulb, and I'm pretty sure that should give us what we need. And it's not coming on full brightness, and we're getting power. That's good. So we're getting B+, and under full power, that B+, when everything's running properly, should be somewhere around 365 volts, according to the schematic up here. Very hard to read, but that's what it is. You can see how that dropped now. So our tubes are starting to conduct. So let's take a look and see what our cathodes look like. So I'm going to remove this. Well, you know what? I'm going to turn this off first and wait for it to drop down. And then I will remove it. There we go. Okay, back on. And let's look at the base of this. Or I'm sorry, at this resistor. And there's your... I'm not touching it very good, but let's see what our cathode bias should look like on there, on that 300 ohm resistor. If we look there, unfortunately, they don't have any... Yeah, they do. That looks like it's saying, I don't know, can you read that? That looks to say 18 volts. All right. And I would imagine that's going to be pretty low right now anyway. I'm only 2.5 because I don't have full power on there. And if I look at these, all of these are cathode bias, by the way. And it says we should have somewhere around 22 volts for the cathodes of the 6550s. So if I go on pin 8 of these 6550s down here, it's going to be this pin here. It's the same thing, it's only reading about 3 volts. And that's because right now I'm only feeding about 67 volts into the amplifier, so it's only half power. So I would imagine that's going to be pretty low. So that's that one there, and if I look here, it should be the same. You see, am I on the correct pin? Yeah, there we go. Okay, that is good. Very good. Okay, so let's go to an even larger bulb. This is a 300 watt bulb. Let's see what happens to our bias now. 11.6. And again, now we have 92 volts. So we still don't have our 120 volts, but that's okay. And let's see what I'm getting. It's about 12 volts there. And let's go back up to this one. And it's about, that's a little bit high. See that? It's saying 10 volts. And according to, oh no, they want 18 on there. So far so good. Now I'm not ready to go full power yet because the next thing we want to do is we want to look at our control grids of each tube to make sure that these capacitors aren't leaking on us right now. So those are going to be coming in on pin 5 of each of the 6550s. So if I look right here, we got, let's see, 1, 2, 3, 4, 5. So it'd be these green ones right here. And there's nothing there. That's good. And if I go to the other side, no leaky there either. And just for giggles and grins on the other side, we got 63 volts. So that's good. Okay. Let's look at the capacitors on, let's see, it looks like pin 3 if I'm reading that correctly. And those are the 0.015s, which are going to be, let's see, am I looking at this correctly? Nothing there. That's good, that's what we want. Okay, so pin 3 we're good there. Pin 3, we're good here. So we're not overdriving our grids, and those capacitors are holding right now, but of course I'm still going to replace them because it's never good to leave those kinds of caps in there, especially at the age that they're at. But the amplifier should work right now. We should be able to amplify a signal. Okay, we have a really convoluted setup here, so let me give you the quick rundown of what we have. First of all, these speakers are not both common to chassis ground. So what do I mean by that? Well, I'm going to get into this one later, but as you can see, this speaker terminal is not normal. It is not what you're used to seeing. As a matter of fact, not only is it a 16 ohm speaker, but it has a center tap that goes through a 125 ohm resistor to ground. And believe it or not, that is your cathode. You can see. So essentially the cathode is what's providing your negative feedback for this. And your feedback is only taking place in the output section. There is no global feedback coming off of here and going all the way back into your preamp stage and phase splitter. So this is kind of a strange setup the way they do this, but it's really cool in another way. Now on the 6973, which is the tremolo amplifier, the low power amplifier, it is a traditional amp. It does not have any feedback either, and it's acquiring its ground, or deriving it's actually tying the output directly to chassis ground. So right now I have a 8 ohm dummy load connected to here, and I also have an 8 ohm load here, which I'm not going to drive signal into it with 8 ohms, but I just want to have something on here to reflect back onto this with 0 signal, just so this thing doesn't kind of get crazy on you. So what I'm going to do is I have an isolated signal generator, just this little battery operated one, and I am feeding the signal directly into the input down here. So I'm going right in here, and it goes into this volume control, and this is what's going to drive this amplifier. And then I have my oscilloscope and my 8 ohm dummy load connected here. So you can see all that. It's a big mess. And yes, I can't even use my normal dummy load because these two resistors have to be isolated from one another. In other words, they cannot be common to one another. So as a result, I'm just using these two resistors that are not tied together. One of them is acting as a load to the one side, the other is acting as a load to the other side, and they're isolated. The other thing, you cannot check both channels at the same time with an oscilloscope because the negative ground probe of your scope will tie the two outputs common to one another. So you can only use your oscilloscope on one channel at a time. So you have to be very careful when you do all this, and your scope needs to be isolated from everything else. Now I can use a differential probe, I can use differential mode, but for right now we can use our negative terminal of our scope. So long story short, here we go. I have the signal on, the signal generator is turned on, and I'm going to rotate the volume up, and I'm going to put you up on the scope as I do this, and we'll see if we have any kind of output. I'll show you here, and sure enough we have a pretty, and I'm on 5 volts per division on the scope, and you can see how it distorts. That's your clipping. That's how vacuum tubes clip. It's a lot softer clip. Instead of turning into that hard flat top clip, they kind of round off, and then you see a little bit of crossover distortion at the same time. That's how an amplifier vacuum tube amplifier clips, or how it distorts. So we're getting a good bit of power out of this, and we can actually measure it now. Okay, I have both in here. I'm going to run this clear up to clipping, and we're going to watch what our RMS voltage is. Right there, it's starting to clip out on us a little bit. And we have 6.4 volts. Okay, and that's RMS. So we take our 6.4 squared divided by 8, and you get 5 watts. That's about what we would expect from that dinky little transformer there, because if you remember, this has that little tiny output transformer there for the 6973. So it's a 5-watt amplifier. It can deliver 5 watts of clean power. And that's what I expected. Now the other side is not so simple, because we're going to have to connect a 16 ohm load, and we can't connect our scope to ground. Actually we can, because I have my whole bench isolated and everything. That's a different whole story. But we can check and see what kind of output we get from that side now, and that's what I'm going to do next. Okay, I very messily have an 8 ohm load still connected to the tremolo channel. I have these 2 resistors wired in series for 16 ohms, and they're on the 6550 high-powered amplifier. And I have my voltmeter and my scope connected. And I hope I can get everything in view once again. And we do. And we're going to just take it up to clipping once again. And I have full power to the amplifier now. And here we go. And look how nice that waveform is. Very, very nice. And let's see, take it up to just about to clipping there. I'm getting just under 21 volts. Let's call it 21 volts. Okay. So 21 squared divided by 21 squared divided by 16. 27.56 watts into 8 ohms. Okay. So getting just about 28 watts. Remember, they call this a 55 watt amp, but that would be 55 watts into 8 ohms. But since we have a 16 ohm signal in there, it's half of that, which is 27 watts. So they're kind of stretching the truth a little bit. If you put a second speaker in there in parallel, and you had an 8 ohm load, it would be, you would see your 50 watts. So there you have it. The amplifier's working, and the signal's pretty clean. I mean, it was really clean on that first channel. And remember, that first channel had no feedback on it at all, but this one does have feedback just on the output section. But see how clean that is. And you can see right there up to clipping, it clips on one side a little bit before the other, but not quite, not too bad. So, and who knows what I'm doing with all the wires stretched around in there and everything I'm picking up. But this thing's perfect. It looks good, and all the voltages are where I want them to be. And so this one's ready to go. So there you go. Amplifier is working, and all we really needed was we just put these 2 little caps here, replaced this one resistor. We added the 2 6550 tubes, or actually KT88s. All is good.